Given quadrilateral ABCD is a parallelogram with diagonals line segment AC and line segments BD intersecting at E. We are going to prove that triangle AED is congruent to triangle CEB. Before we do anything, we want to highlight the diagonals that were given. So I'll highlight diagonal line segment AC as yellow and diagonal line segments BD as green. Now we want to prove that triangle AED is congruent to triangle CEB. So we want to pick two colors and we want to identify what those two triangles are. So I will highlight triangle AED as red and then I'll highlight triangle CEB as green. Now we are going to describe a single rigid motion that maps triangle AED onto triangle CEB. And we want to do this by identifying the corresponding points. So A should map onto C, and E should map onto E. And lastly, D should map onto B. Now I know that it's not a reflection because if I fold over a point or a line, A in yellow would not map onto C. So we want to match the colors, right? And I know that D is not going to map onto B. And so I know that it's going to be a rotation because A and C are currently in opposite corners. They're like upside down right now. So A is on top, and then after a single rigid motion, now it should map onto C, which is on the bottom. So we're going to write that triangle AED rotated 180 degrees, and this can be clockwise or counterclockwise because remember, it doesn't matter which direction you go for 180 degrees. Now we have the degree, we have the direction, we need to say it's centered around point E. Remember, when we're describing a rotation, we need those three things: degrees, the direction, and where the center point is, where it's rotating. So because it's off a grid, we need to describe it using letters and using points that we are given. And we're going to say it rotated 180 degrees clockwise or counterclockwise, centered around point E, to map onto triangle AED. All right, now that we know it was a rotation, not a reflection, we can move on to proving that triangle AED is congruent to triangle CEB. How we're going to do that is by using a two-column proof. So we're going to write on the left side all of our statements. And then on the right side, we're going to write all of our reasons. We want to first look at the diagram and see if anything is marked. If anything is marked with, let's say, line segments with tick marks or angle measures with arcs, then those are given to us. But we don't currently see any. So we're going to look at the statement itself. There's a given statement. And again, it says quadrilateral ABCD is a parallelogram with diagonals line segment AC and line segment BD intersecting at E. So this whole statement that is given, we need to then write it as our first statement, exactly as it was given to us. So let's transfer that over. Take a moment to pause this video so that you can also write the given, and then think about what you would write for the second statement. Given our first statement, why did they give us this statement is what you're going to ask yourself. So you want to begin to think about properties of a parallelogram, and specifically they mentioned something about the diagonals. So maybe it would be helpful for you to go back to properties of parallelogram and look specifically at what's special about the diagonals for all parallelograms. So for example, rectangles, squares, rhombuses. Okay, now we're ready for the second statement. If you remember, what's special about a parallelogram and its diagonals is that diagonals bisect each other. So I'm going to write here for my second reason in a parallelogram. Diagonals bisect each other. What that means is that it cuts each other in half. The diagonals cut each other in half. So I'm going to mark that in my diagram. Line segment AC that we first highlighted in yellow, we're going to cut in half so that line segment AE is congruent to line segment CE or EC. And not only that, but if you take a look at line segment BD, it is also cut in half. So I will mark this with 2 tick marks this time. Because remember, we don't know that the 2 diagonals themselves are congruent, but they are each being cut in half. So the second one is going to be that line segment DE is congruent to line segment BE or line segment EB. And we know that again because we looked at the properties of a parallelogram, and we remember something about the diagonals bisecting each other. And now we already have 2 sides, S and S, for both triangles. We're missing either an angle or another corresponding side length. So remember that whenever you can use side, that's what you're going to do because it's just the easiest. So we can say number 3 is that line segment AD is congruent to line segment BC. Let's make that more visible. And my reason is, if you remember, again, properties of a parallelogram, that in a parallelogram, opposite sides are congruent as well. So go ahead and write that as your reason. And now we have all 3 corresponding sides being congruent to one another. We can write our 4th and final statement. The 4th and final statement comes from the proof statement. Since we want to prove that triangle AED is congruent to triangle CEB, we will write triangle AED is congruent to triangle CEB. And our reason for that is because of the side triangle congruence theorem. And again, like we discussed in class, side, side, side is not the only triangle congruence theorem that we can use to prove that these two triangles are congruent. You can also talk about vertical angles being congruent. So you can say that angle AED is congruent to angle CEB. And then you can use side angle side. You can also talk about alternate interior angles because we have that this is a parallelogram. So we know that line segment AB is parallel to line segment CD. Therefore, we know that angle CAD is congruent to angle ACB. And so we can say that those two angles are congruent because alternate interior angles are congruent. And therefore, we can either do angle side angle or side angle side.